A linear equation is an equation between two variables that creates a straight line when plotted on a graph. Here's an example: x equals 1, y equals 1 and x equals -1, y equals -1. The general form of the equation of a straight line is ax plus by plus c equals 0. The main features of a linear equation are it is a straight line and it always intercepts the y-axis. There are many ways of writing linear equations, but they usually have constants like 2 or c and must have simple variables like x or y. The equation y equals mx plus b is the equation of a straight line. M represents the slope or gradient of the line and b is the y-intercept where the line would pass through the y-line on a graph. A translation moves every point by a fixed distance in the same direction. The movement is caused by the addition or subtraction of a constant from a function. For example, the red line equals to f x equals x. After substituting the base function with x plus 2, the function becomes f x plus 2 equals x plus 2, which is the blue line. On the other hand, a reflection of a function causes the graph to appear as a mirror image of the original function. This can be achieved by switching the sign of the input going into the function. For example, if we take the line y equals 3 by -1 and translate it up by 2 in the y direction, we get y equals 3x minus 1 plus 2 or just y equals 3x plus 1. If we take the same line y equals 3 by -1 and translate it by 2 in the x direction, then the equation changes more subtly to y equals 3 x minus 2 minus 1. Another example, the transformation r, x, y 2 x, minus y sends every point to its mirror image in the x-axis. If we perform this transformation twice, we get back to where we started.
A quadratic function is one of the form of f(x) equal to x squared plus bx plus c, where a, b, and c are the number not equal to 0. The general solution of a quadratic equation is x equal to -b plus minus square root b square minus 4ac over 2a and b square minus 4ac, known as a discriminant. The key features pf: the quadratic's graph is U-shaped and the vertex is 0, 0. The graph of the function is called parabola. The shape of it depends on the value a, means the coefficient of x square. If the value of a is smaller than 0, the turning point of the curve is a maximum point, and it occurs at the highest point of the curve. If the value of a is greater than 0, the turning point of the curve is a minimum point, and it occurs at the lowest point of the curve. The quadratic equation can be changed to a bracket x minus h square plus k. A quadratic function is a function that can be written in the form of f(x) equal to a bracket x minus h square plus k. For example, question given the formula f(x) equal to x squared plus 5x plus 3. We know that a equal to 1, b equal to 5 and c equal to 3. As we see, the value of a is greater than 0, so the turning point of the curve is a minimum point. Now we need to find the vertex of parabola. The formula to find the x value of vertex is -b over 2, so we get x equal -5 over 2. The formula to find the y value of vertex: if f bracket -over 2, we just have to insert the x value of vertex into the quadratic formula they're given, and you will get y equal to -3.25. After find the minimum point, we still have to find 2 to 3 points to form a curve. If you put x equal to -5 into the quadratic formula, you will get y equal to 3, and put another x value which is x equal to 0, and you will get y equal to 3. The quadratic function only have two translation. If the question asks you to find a translation of fx minus a, is just to shift to the right, and how many space you have to shift is depend of the value they given. If the question asks you to find a translation of fx plus a, is just to shift to the left. If the question asks you to find a translation of f bracket x and plus a, is just to move upward. If the question asks you to find a translation of f bracket x and plus a, is just to move downward. The quadratic function have two reflection. One is f bracket -x. It is just reflect the curve across a y-axis. Another one is negative f bracket x. It is reflect the curve across the x-axis. Bracket.
This is the introduction of square root functions. It is also known as radical function. The basic formula is y equals square root x. For example, x equals 4, y will equals 2. Let's try placing 0, 1, 4, 9, and 16 in the basic formula as well as plotting it in the graph. And here's the plotted graph. Y equals square root x in Desmos. You will get a graph like this, and on the left side here you can see that there are specific coordinates I picked out. The reason why I picked them out is because that is where the line passes through without the number being a decimal. Moving on to radical function and translation. The basic formula for this is f(x) equals square root x minus a plus b. For example, f(x) equals square root x plus 1 plus 1. You get a graph like this, but if you were to change it into f(x) equals square root x plus 1 plus 5, it will expand by 5 vertically. Or change it to f(x) equals square root x plus 2 plus 1, it will translate horizontally by 2. Moving on to reflection. Here's an example of what y equals negative square root x would look like in the graph. If you change it to y equals negative 3 square root x, it will vertically expand by 3. Adding a 6 would make it vertically reflect by 6. Here is an example of changing a graph form into an equation. There are two types of method. The first one would be comparing distances of the graph, and the second would be substituting a chosen point into the formula y equals square root x minus a plus b. Finally, using the basic function y equals square root x to solve this question. To calculate VE and VR, the red one, take y from y equals square root x times itself, which is 1, 2, 3, 4 to solve x coords. Then y times negative 3 to find the y coord. To solve HT and VT, the blue one, take negative 2 plus the x from VE and VR, and 4 plus VE and VR's y. And last but not least, the summary of the entire square root function.
Okay, here we have cubic functions. Now, before we dive into all the translations and reflections for the functions, let's first start with the basics of a cubic function. First off, let's start by identifying what makes a cubic function. For starters, a cubic function has a highest power of 3. This means it has 3 roots. The other feature about cubic functions is that it has 4 coefficients: a, b, c, and d. The unique feature of cubic function is when plotted into a graph, the graph will be shaped similarly to trigonometry graphs. Some cubic functions have a relative maximum point and a relative minimum point depending on the roots. If the 3 roots are all equal, there is no relative maximum points nor relative minimum points. If the 3 roots are different, or at least one of them is different, then the graph will look like a sin graph and will have a relative maximum point, which is highest turning point before it decreases, and a relative minimum point, which is lowest turning point of the graph. Relative maximum point and relative minimum point of a cubic function can be calculated with differentiation as shown here. Now moving on, we have translations. We will start with the x plus a translation where greater than 0. What this means that the graph will shift to the left along the x-axis. If the value is less than 0, it means the graph will shift to the right along the x-axis. Next we have the translation f(x plus a). If the value is greater than 0, the graph will move upward along the y-axis. If the value is lesser than 0, the graph will move downwards along the y-axis. For reflections, if the negative sign is integrated into the f(x) function, the reflection is on the y-axis. If the negative sign is in front of the f(x) function, it means the reflection is on the x-axis. That's all for translations and reflections.